Hello everyone. In this explanation, we are going to learn about Dekker's algorithm. Here I had mentioned the key points of Dekker's algorithm. Now let's start. Dekker's algorithm uses Tron variable and Boolean variable called flag. Here Tron variable is used to point the or used to give the Tron to the process to enter the critical section, and variable called flag is used to determine whether the process want to enter the critical section or not. Now in the next point, this it is said that this algorithm is only applied for two processes at a single time. It means that two processes can be processed at a single time. If, if two processes want to enter the critical section, then this algorithm will allow only one process in, depending on which turn is it. If any one process is already in critical section, then the other process will wait until that process is finished. Now, it is the first non-correct software solution to the mutual exclusion problem in concurrent programming. Now, let's see the pseudocode. As you had already known that mutual exclusion is doing only one process at a time. So now, in the pseudocode, we had create a shared variable and create a flag array of size 2 and mention it is false. Array to indicate the desire of each process to enter the critical section, and a tron variable to indicate which tron is it. Now let's go to the process 0 pseudocode. Here I had explained all the line is each line by line. Now let's see. While true, it means an infinite loop that keeps the process running. The flag 0 equals to true means flag 0 index equals to true. Process, it means it's a process 0. It indicates its intention to enter the critical section. Now while flag 1 is true, process 0 checks if process 1 wants to enter the critical section. Now, if tron equals to 1, it means process 1. It's process 1 tron. Flag 0 equals to false. Flag 0 equals to false means process 0 withdraws its intention to enter the critical section. While tron equals to 1, process 0 waits until it's tron again busy waiting. It's called busy waiting as it is a busy waiting problem. Now, again we assign true to the process 1. For process 1 flag is true, process 0 reframes its intention to enter the critical section. Now, it enters the critical section and it makes the tron and gives the tron to the process 1. Here, process 0 is here, and here, process 1. Please cooperate. Here, now let's see the pseudocode for process 0. The first term is while true means an infinite loop that keeps the process running. Here's the pseudocode and here's the explanation or comments. Now, while flag 0 equals to true, it means process 0 indicates its intention to enter the critical section. And while flag 1, process 0 checks if process 1 wants to enter the critical section or not. Now, if again we check if tron equals to 1. If tron equals to 1, then it's process 1 tron. Again, if flag 0 equals to false, means now no. Yeah, now let's see the pseudocode of process 0. Here, while true, it means an infinite loop that keeps the process running. Here are the comments and here are the pseudocode. While flag, it means no. Now let's start the pseudocode for process 0. Here are the pseudocode and here are the comments. Now, here first point is while true. It means an infinite loop that keeps the process running. In flag 0 equals to true, we assign true to the flag 0 index. It means process 0. Process 0 indicates its intention to enter the critical section. And then while flag 1 while process means process 0 checks if process 1 wants to enter the critical section. Now then we check if tron equals to 1 or not. If it is 1, then process 1 trons. Again, flag 0 equals to false. It means process 0 withdraw the intention to enter the critical section. Process 0 withdraw the intention to enter the critical section. Then While till tron equals to 1, we busy wait it as it is a busy waiting problem. So process 0 wait until it's tron again, its turn come again. Now we assign true to flag 0 of process 0. So process 0 reframes its intention to enter the critical section. Then it enters the critical section. Process 0 executes its critical section code, and then process 0 gives tron to process 1 as it makes tron equals to 0 to tron equals to 1. Now flag 0 equals to false means flag 0 equals to false means process 0 withdraws intention to enter the critical section, and the after the reminder section it will execute. Now let's see the code of. Here is the pseudocode for process 1. It is as same as process 0, but we will check in reverse direction. Now while true, it is same an infinite loop that keeps the process running. Flag 1 equals to true means process 1 indicates its intention to enter the critical section. While flag 0, process 1 checks if this means process 1 checks if process 0 wants to enter the critical section or not. Then if tron equals to 0, if it is right, then process 0 it is process 0 tron. Now flag 1 equals to false. Flag 1 withdraw its intention to enter the critical section. This means then while till tron equals to 0, we are waiting and busy waiting until its flag process 1 trons come. Now flag 1 equals to true, it means process 1 reframes its intention to enter the critical section. Then it enters the critical section and executes its code and makes the tron variable to 0 and gives process 0 the tron. Now flag 1 equals to false means process 1 withdraw its intention to enter the critical section. So it's the reminder section. Now we now talk about drawbacks of Dekker's algorithm. One main drawbacks of Dekker's algorithm is busy waiting. Means this means that while one process is in critical section, the other process continuously checks if it can enter the critical section, consuming CPU resources without doing any productive work. This can lead to the insufficient use of CPU cycle, especially in the system where resource utilization is critical. You can read here. Here are the here is the one main drawback of the Dekker's algorithm. Now this much for today. Thank you. Stay updated.